Ever wondered what the difference between AI and neural networks is? Well, you've come to the right place. In this video, we're going to explore the fascinating world of artificial intelligence, or AI and neural networks. But before we dive into the deep end, let's take a moment to understand what these terms mean. Artificial intelligence, in broad strokes, refers to the ability of machines or software to mimic human cognitive functions, such as learning and problem-solving. On the other hand, neural networks are a specific type of AI inspired by the human brain designed to recognize patterns and make decisions based on those patterns. So, in essence, while all neural networks are a form of AI, not all AI systems utilize neural networks. Now, isn't that intriguing? So buckle up and prepare to embark on an enlightening journey as we delve deeper into these concepts. Stick around to unravel the exciting world of AI and neural networks. To start with, artificial intelligence is not as artificial as it sounds. It's a fascinating blend of science and imagination, aiming to create machines that mirror human intelligence. But let's take a step back and look at where it all began. The concept of artificial intelligence, or AI as it's commonly known, was born in the mid-20th century. Pioneers like Alan Turing and John McCarthy dreamed of machines that could mimic human thought processes, and their work laid the foundation for what we know as AI today. At the heart of AI is the idea of creating machines that can think, learn, and act like humans. That's a hefty goal, isn't it? But it's not just about mimicking human intelligence, it's about augmenting it, enhancing it, and even surpassing it in some cases. Now let's delve into its different forms. First off, we have narrow AI, which is designed to perform a single task, like voice recognition. It's the kind of AI you encounter when you ask your smartphone to set an alarm, or when your car's GPS navigates you to a destination. It's pretty smart, but it's limited to its programmed tasks. Then there's general AI, a more advanced form that can understand, learn, and apply knowledge across a broad range of tasks. This is the kind of AI that science fiction loves to portray, but it's still largely theoretical at this point. Finally, we have super-intelligent AI. Now this is where things get really interesting. Imagine an AI so advanced that it surpasses human intelligence in practically every aspect. It could solve problems that we can't even comprehend, and it might even redefine our understanding of intelligence itself. It's an exciting, if somewhat daunting, prospect. AI, in its essence, is about creating machines that can think, learn, and act like humans. Whether we're talking about a simple voice assistant or a hypothetical superintelligent entity, the goal remains the same: to create a machine that can match or even exceed the capabilities of the human mind. Now, neural networks are a different ballgame altogether. To start, let's conceptualize neural networks. Picture a web of interconnected nodes or neurons. Each neuron takes in a set of inputs, processes them, and passes the output to other neurons in the network. This is a simplified model of how our brain's neurons interact, hence the term neural networks. Now, these networks operate on a system of weights and biases. Each input is assigned a weight, reflecting its importance. Biases, on the other hand, allow for flexibility in the network's output. The magic happens when these weights and biases are adjusted during the process known as training. Through repeated exposure to data, the network learns to optimize these values to produce the desired output. But how is this structure organized? Well, neural networks consist of multiple layers. The first is the input layer, which receives raw data. Then there's the output layer that delivers the final result. Between these two, we have what's called hidden layers. These layers perform complex computations and transformations, essentially driving the learning process within the network. Now, you may ask, what's the role of neural networks in AI? Well, they bring the intelligence to artificial intelligence. Neural networks enable machines to learn from data, identify patterns, and make decisions, all without explicit programming. They're the engines behind many AI applications we use daily, from voice assistants to recommendation systems. But remember, neural networks are not the be-all and end-all of AI. They are one of many mechanisms in the vast toolbox of artificial intelligence. Different tasks may require different tools. For instance, rule-based systems are more suitable for tasks where the rules are clear and well-defined, while neural networks shine in tasks involving pattern recognition and prediction. So even though neural networks are complex and intricate, their role in AI is straightforward. They learn from data, identify patterns, and make decisions, driving the intelligence in artificial intelligence. In essence, neural networks are the building blocks that make AI possible. So, how do AI and neural networks stack up against each other? Well, let's delve into that. To understand the relationship between artificial intelligence and neural networks, we need to uncover a few fundamentals. Artificial intelligence, or AI, is a broad field of study that seeks to create machines that mimic human intelligence. It's like an umbrella, under which several techniques and methods fall, and neural networks is one of those techniques. Now, neural networks are fascinating. They are essentially computational models that mimic the human brain structure. They learn from data inputs, much like how we learn from experiences. By processing these inputs through layers of interconnected nodes or neurons, they can make predictions and decisions without being explicitly programmed to perform the task. So in essence, neural networks are a subset of AI, a tool in the AI toolbox, if you will. They help AI systems to learn and improve over time, making them more human-like in their functioning. However, it's essential to realize that AI isn't just neural networks. There are other techniques and methods used in AI, like fuzzy logic, genetic algorithms, and reinforcement learning, to name a few. Each of these methods serves a unique purpose, and neural networks are no different. They are particularly adept at handling vast amounts of data and recognizing patterns within that data. This makes them ideal for tasks like image and speech recognition or predicting trends in massive datasets. However, while they are an integral part of AI, they are not the entirety of AI. They are just one piece of the puzzle, one cog in the machine. AI is a vast and complex field, and while neural networks play a significant role, they are not the sole players. In the grand scheme of things, AI is the all-encompassing concept, and neural networks are one of the many techniques used to implement this concept. They work hand in hand to create intelligent systems capable of learning, reasoning, and making decisions. While neural networks are a part of AI, they are not the be-all and end-all of AI. Now, let's dive into the main differences between AI and neural networks. Artificial intelligence, or AI, is a broad concept that encompasses the idea of machines or software exhibiting intelligence akin to that of humans. It can be broken down into two main types: narrow AI, designed to perform a specific task like voice recognition, and general AI, which can perform any cognitive task that a human being can. On the other hand, a neural network is a subset of AI. It's a computational model designed to mimic the human brain's neural structures. It learns from observational data through a process known as training, and once trained, can make predictions or decisions without being explicitly programmed to perform the task. Here's a simple analogy. If AI were a car, a neural network would be the engine that powers it. The car as a whole is capable of getting you from point A to B. That's your artificial intelligence. The engine, the mechanism that enables the car to move, that's your neural network. Now let's talk about their applications. AI is everywhere around us, from virtual assistants like Siri and Alexa to recommendation systems on Netflix or Amazon. It's also used for more complex tasks like diagnosing diseases or driving autonomous vehicles. Neural networks, meanwhile, are the driving force behind many of these applications. They're used in image and speech recognition, natural language processing, and even in creating art. They're the backbone of deep learning, enabling us to build more complex and efficient AI systems. Finally, let's consider their limitations. While AI can perform tasks that normally require human intelligence, it's still limited by its programming, and doesn't truly understand or experience consciousness. Neural networks, on the other hand, require a lot of data and computational power for training, and their black box nature makes it difficult to understand how they arrive at a particular decision. As we've seen, while AI and neural networks are closely related, they are distinct in their own right. So there you have it, the difference between AI and neural networks, demystified. We've delved into the vast realm of artificial intelligence, unpacking its principles, capabilities, and wide range of applications. We've also journeyed into the intricate world of neural networks, a specific implementation of AI, exploring its structure, functionality, and the unique ways it mimics our brain's neural processes. In comparing the two, we've illuminated the key differences. While AI is a broad concept encompassing various techniques and algorithms, a neural network is one particular mechanism within this expansive field. It's a subset of AI, a tool in the AI arsenal, if you will, not the entirety of artificial intelligence itself. Understanding these distinctions is crucial as we navigate this ever-evolving technological landscape. It enables us to grasp the immense potential these technologies hold and how they can be harnessed to shape our future. Remember, the future is